Hello and welcome to another video. I finally got round to doing the linear regression questions in the statistics papers. I've got linear regression to do and the discrete random variable stuff to do. I think that's the other topic. They tend to be the 5 topics which come up. I've already done probability, normal distribution, and what else have I done? Probability, normal distribution, and I can't remember what the other topic is. I'll have to quickly check on my YouTube channel. Let's have a look. It was probability. Oh, and the sampling questions. Yeah, they're pretty dry as well, to be honest. I've always found these not really so fun to do mathematically, and that's why I've left them until last. But they are important. They're in the exam, and the nice thing is they are questions you can definitely get lots of marks on. They tend to have lots of waffle in them, yeah, and that's why I'd always encourage you. I always encourage my students anyway to have a go at writing down the answers to the waffle questions, and then at the end always compare your answers, looking very carefully at the notes for what's acceptable and see how close you're getting. You'll find over time that you gradually get better. Anyway, let's start. So this is question 2 from 2018. It's on regression and correlation. They tend to go hand in hand. Remember, regression is, if you like, a perfect line of best fit, like a mathematical way to decide the perfect line of best fit. Correlation is a measure of how close the points lie on a scatter graph to a straight line. So they're very related ideas, but they're not the same. Yeah, one kind of supports the other. If the points lie close to a straight line, i.e. r is close to 1 or minus 1, then coming up with a linear regression model is a good idea. Yeah, you can trust the model more. Okay, let's get on with it. So Tessa owns a small clothes shop in a seaside town. She records weekly sales figures, which is in W pounds, and the average weekly temperature, which is in degrees Celsius and measured as T, for 8 weeks during the summer. The PMCC, the correlation coefficient, is minus 0.915. Now, straight away I'm thinking, well, R is always trapped between minus 1 and 1, and this is very, very close to minus 1, so this is implying almost perfect negative correlation. That's what it looks like to me. But they want us to do a hypothesis test first, so let's do it. Now remember, on hypothesis tests, when you're doing hypothesis tests for correlation coefficient, you don't use R. You use rho. Yeah, you might wonder why that is. Yeah, I'll describe it in a second. It looks like P. All the students will say P, but it is actually a Greek letter called rho. It's slightly different to P. Okay, the null hypothesis is always that there's no correlation. Yeah, and that would be that rho equals 0. And remember, rho is just like R. Yeah, you might wonder what the difference is. Let me quickly tell you. It's not important really to getting the question right, but this is what's known as a population parameter. And so it's about the population rho, whereas this is known as a sample parameter. Yeah, it's the same as the difference between x bar, which is for a sample, and mu, which is for a population. Yeah, population parameters tend to have Greek letters, sample parameters don't. Yeah, so if it's a Greek letter like sigma, for example, for standard deviation, that represents a population parameter. Greek letters tend to represent population parameters. So there you go. It's not massively important. You just need to remember they will want you to use rho for your hypotheses. So null hypothesis, rho equals 0. Alternative hypothesis. Now, did they give an indication whether there's a bias here, whether it's positive or negative? Test whether or not the correlation between sales figures and aggregate weekly temperature is negative. Yeah, so that's going to be rho is less than 0. Make sure these don't overlap. Don't do that. That's wrong, because otherwise they overlap. Okay, that's our null and alternative hypothesis. Using the 5% level of significance, test whether or not the correlation between sales figures is negative. Okay, so we're going to now look at this, and we're going to think, how many items of data did we have? Well, they did it for 8 weeks, yeah? It was average weekly temperature for 8 weeks, which means there are 8 items of data. So n equals 8. And so I'm testing a one-tailed test at 5%, and the sample size is n equals 8. You're going to have to go to this, which is in the formula book. It's critical values for correlation coefficients. Go across at 8. We want 5%. The relevant value is 0.6215. Yeah, but these are all the positive values, and we want the negative ones. So I prefer to straight away say, well, the critical value, let's call it a CV, is minus 0.6215, and as minus 0.915, I think it was. Let's just check that. Yeah, minus 0.915. That is more extreme, more closer to minus 1 than minus 0.6215. That that shows that there's correlation, doesn't it? It's such a strong value. You have to beat these values. This is the way I put it. You have to beat them or be more extreme than beat these values, i.e. if it's positive, closer to the 1, but if it's negative, closer to the -1, to start accepting the alternative, yeah, and rejecting the null, yeah. So this is like a test figure, if you like. That's what a critical value is. It's a test figure. If you can be more extreme than that, then we start accepting the alternative hypothesis. So now I need to say, so accept H1, sufficient evidence to suggest that there's negative correlation. And I'm going to put it in context as well, because I know they like remarks in context in the conclusion. There's negative correlation between sales figures and temperature. Yeah, I don't like writing this bit down either, but I like getting the marks. Between sales figures, well, sales and temperature. That should do. We'll check it at the end because I've actually copied the mark scheme to the right so we can see how many marks I get. Because I'm always interested. I like doing the wordy questions and then comparing my answers because I think it's the best way to improve. Okay, suggest a possible reason for this correlation. A reason for the correlation, yeah? This is not a mathematical question. This is a, what do you think happens on a sunny day question? Yeah, I know sometimes it's hard to detect when they want a maths answer or whatever. Certain words give it away. If they ever use the word interpret, it's always about the context of the question. But they want a reason for the correlation. So this must be a reason for why sales figures would go down as temperature goes up. Well, you just need a plausible reason, really. Something like, on a hot day, people may not want to go shopping. People may not want to be traipsing round the shops. That's the way I'd put it. May not, certainly I wouldn't want to be, may not want to be traipsing, is that even a word, around the shops. Have I spelt it right? Probably not. Yeah, you don't want to be traipsing around the shops on a hot day. Hopefully that will do. We'll check it in a second because, like I said, I've got the mark scheme to the right of me. Hopefully it's all right. Just suggests that a linear regression model could be used to model these data. Now, they love asking this question, whether you understand the connection between correlation and linear regression. Now, this is what they're saying here. State giving a reason whether or not correlation coefficient is consistent with test suggestions. So they're really directing you to it. They're saying your R value, which is minus 0.915, that's showing very strong negative correlation. Do you think it's worth doing a linear regression model? And the answer is yes. As the points lie very close to a straight line, as the points lie close to a straight line, R equals minus 0.915, yeah, this suggests that a straight line, this suggests a linear model would be very appropriate. And I'm just going to finish there writing that down. Okay, so I hope you understand that as well. The whole point is we could always do a linear regression, we could do a linear regression model on any set of data. But what would be the point if your set of data looked like this, yeah, all over the shop, just your scatter graph is just a mess, yeah? What's the point in doing a linear regression model? You could come up with the A and B for the y equals a plus bx. You can generate that on a calculator, and it might look something like this or something like this. But does it really give you an idea, a good model of the situation? No, it doesn't. It's only if the points lie really close to a straight line, i.e. the R value is very close to 1 or minus 1, that you should bother doing a linear regression model. And so that's all you want to say. We'll check in a second what they say in the mark scheme. State giving a reason which variable will be the explanatory variable. So once again, this topic is really about, knowing your terminology, yeah? Most people are familiar with independent variable and dependent variable. Well, and by the way, the independent variable tends to be put on the x-axis and should be put on the x-axis, and the dependent variable is on the y-axis. Well, another name for these is explanatory and response variables. Explanatory is the independent, and response is the dependent, yeah, because it responds to the explanatory one. One explains the other, if you like, and one responds to the other. So this is a response variable. So what do we think in terms of our context? where we've got sales and temperature. Does the temperature recorded on a day depend on how many goods are being sold, or do the number of goods being sold depend on how hot it is? Quite clearly, the only way around which makes sense is that temperature is the explanatory variable, as sales depend on temperature. As sales depend on temperature. Okay, that's cool. Okay, Tessa calculated the linear regression equation as this. Okay, they never ask you to calculate that on your calculator for some reason, because it's easy to do, but you may be asked to find R on your calculator, so bear that in mind. Okay, interpretation, yeah, that always means comment in context. So if our regression equation was this, what is the gradient representing? Well, firstly, look at it like this. If T is 0, W is 10,755, and W is sales that week. So this suggests that they always get, at 0 degrees Celsius, the sales would be 10,755. But it suggests that for every time T changes by 1, the sales drop by £171. Yeah, and so that's what they're looking for in interpretation. Interpretation always means comment in context. So I want to say, well, this implies that £171. Yeah, let's put it like this actually. For every time T changes by 1, in other words, every time the temperature drops by 1, temperature drops of 1 degree Celsius correspond to a sales drop of £171 that week. Yeah, that's what the model is telling us. Yeah, for every time the temperature increases by 1 degree Celsius, sales drop by £171. And that is it. Now, I just want to quickly do this, and I strongly suggest you do the same thing with these wordy questions in mechanics and stats, actually. Always have a go at the wordy thing first, and then see if they'll accept your answer. So this was fine, obviously. As temperature increases, people spend more time on the beach and less time shopping, or equivalent. Now, if you look here, any suitable reason to explain it. As temperature drops, people are more likely to go shopping. Yeah, they've done it the other way around. As temperature increases, people would rather be outside. A mere description in context of negative correlation is B0. Yeah, this is interesting. They're giving you, look, as temperature increases, people, am I getting B0 here? That's so nasty. As temperature increases, people don't want to go shopping, buy clothes, is B0. What? I think that's so harsh. There we go. I'm not getting the marks here. On a hot day, people may not want to be traipsing around the shops. Now, let me just try and understand what they're really saying here. Using the context given, we've got to give a reason. Yeah, we've got to give a reason they're not going in. Well, they don't want to be traipsing around the shops. Have I given a reason there? I might get that, but I'm just really worried because they're saying here that a mere description in context is not allowed. Yeah, so as temperature increases, people don't want to go shopping. You haven't given a reason. I think that's really harsh. Less clothes needed as temperature increases. Obviously, that's ridiculous. That's I don't know, but that's really interesting. They want it really, really, really precise there. They could argue basically that I haven't given a strong enough reason. So you might, they want you to say they're going to the beach. A hot day, people may not want to be traipsing around the shops. They will want to be in the park. Yeah. Wow, that's harsh. Yeah. And this is why I don't particularly like these waffly stats questions. So I don't know if I'd get away with that one. For suitable correlation, strong, significant, near perfect correlation, and saying it's consistent with a suggestion, that's fine. I think I've got that. Yeah, you can definitely, I've seen it on other mark schemes where they say points lie close to a straight line. This suggests the linear model will be appropriate. And part D, for identifying T, and yeah, W depends on T, that's fine. Yeah, and then part A for a description, crazy idea of rate per degree Celsius, must have 171, condone a missing pound sign. So there we go. Do have a look at these, because like I say, they can be mega fussy sometimes. I think that's mega fussy. Let me know in the comments if you think that is ridiculous, or indeed if you think they're absolutely fair and I deserve to lose the mark there. It's completely up to you. Okay, keep up the hard work, and well done. Bye-bye.